Hello, my name is Felipe Valdia and I'm going to do problem 21 from chapter 9 of our physics book. So, we're asked to calculate the mass of two interacting stars which are in an orbit with no object near it. So, the only force is just the potential force between them. So, we have to write the F net perpendicular, which is just G, mass of star 1, mass of star 2, over R1 plus R2 squared. Note that this can be written as force and not energy because the radius is squared. When there's no square, then it's just energy, potential energy. So now we go to the second part. Normally, F net for us, F net perpendicular, is mv squared over r. So now we implement that in our equation, putting mv squared over r. Remember, this is m1 and v1 squared over r1 equals g m1 m2 and our distance. So now, as you can see, we can scratch out both masses, and now we can solve for m2, which is just m2 equals the velocity squared of mass of star 1 over the gravitational constant times our distance in our potential energy equation over r1. So we're told that the time of revolution that it takes, it's a circular orbit, so t is 40 days. When we transform that to seconds, we get 1.26 times 10 to the 9 seconds. Because it's also a circular orbit, we can rewrite the velocity as 2 pi r over t. So now we do that, and we're left with this equation. It's m2 equals 4 pi squared, because the velocity is squared, over the potential the gravitational constant times r1 over t2